Hello, welcome to the video lecture series on formal languages and automata theory. In today's video lecture, we will be learning about a concept called as Greibach normal form. So, this is one of the prominent form next to Chomsky normal form. So, we will first learn about what is the standard format for Greibach normal form. So, the valid forms of Greibach normal form is there should be a non-terminal on the left side. On the right side, you can have a terminal followed by a collection of non-terminals. And the second is you can have a non-terminal on the left side, right side you can have only one terminal. So this is the standard forms of Greibach normal form. Now we'll learn about the examples which pertains to that. So A tends to small a, capital B. This comes under the first standard form of Greibach normal form. And the second is X tends to B comes under the second format for Greibach normal form. N tends to terminal on the right side, only one terminal on the right side. Now we'll learn about the rules which pertains to Greibach normal form. The first rule is there should not be any existence of unit or null productions. In case if it exists, that has to get eliminated. So in case if there is epsilon productions or unit productions, you have to get rid of the productions before proceeding for Greibach normal form. The second is we have to ensure whether the production is of Chomsky normal form. So the prerequisite for converting into a Greibach normal form is the normal form has to be in Chomsky normal form. Then only you can go for Greibach normal form. The third is you have to name all the non-terminals in the productions into ascending order of AI. That means the first non-terminal has to be named as A1, second non-terminal has to be named as A2, so on and so forth. And the rule number 4 is if a production is of the form AI tends to AJB, whereas the value of I is actually less than J. So this kind of format is getting accepted in Chomsky normal form, Greibach normal form. Suppose if this production is actually the vice versa, that is I value is greater than J or equal to J, then such kind of production is not accepted. In some mechanisms we have to apply to convert that to Greibach normal form. So in case if a production A tends to AJB, whereas I and J are equal, that means the left side non-terminal and the right side non-terminal are equal. Okay, in that case, such kind of production is called as left recursive production. So we have to get rid of left recursive production here. So we will take up a standard form for left recursion. A tends to A alpha, that is left side A and right side A are equal. So this is the production which is causing left recursion, and we have other non-recursive productions spanning from beta 1 to beta n. So in case if left recursion occurs, what we have to do? So now we take all the non-recursive productions spanning from beta 1 to beta n, assign that to left recursive production, that is A, assign left recursive variable, that is A, then add Z to all the non-recursive productions. So spanning from beta 1 to beta n, we have to add Z to that. Then now you introduce a new variable called as Z variable. So whatever which is after the left recursive variable, after A, okay, we have alpha. Okay, introduce Z tends to alpha, then add Z to alpha itself. So this is the way of actually eliminating a left recursion. Now we will work on the problems which pertains to Greibach normal form. So S tends to AB, bar BC, B tends to B, C tends to D, and A tends to small a. Now there is not any unit or null productions here, so condition 1 is getting satisfied. Now when you take up condition number 2, we can see that everything is in Chomsky normal form. Okay, so now condition number 2 is also getting satisfied. Now go for condition number 3, that means rename all the variables into A. Now spanning from A values to all non-terminal. So S is the first non-terminal, so we name it as A1. A is the second non-terminal on the right, so name it as A2. B is the third non-terminal on the right, that is A3. Again when you go on the right you have B. B has been already named, so no need to rename it again. Then when you go after B, C is a non-terminal, then that has to be named as A4. So now rewrite the productions. When we rewrite the production, A1 tends to A2, A3, and A1 tends to A3, A4. So A3 tends to B, A4 tends to D, and A2 tends to A. When we rename it, now when we check it out the productions, the first two productions A1 tends to A2 A3 and A1 tends to A3 A4. Now these two productions actually falls under the category of AI tends to AJ, whereas I is less than J. So A1 is less than A2 in the first production, isn't it? Then A1 is less than A3, that is in the second production. In both cases, I value is less than J. So this is perfectly valid and it is accepted. But still, these two productions are not in Greibach normal form. That means the Greibach normal form should always start with the terminal. It should not start with the non-terminal. So A2 is a non-terminal and A3 is also a non-terminal. So it is starting with the non-terminal. So what we have to do to convert that into a Greibach normal form? That means we have to replace the values. Substitute A2 and A3 in A1. That means A2 value can be substituted with small a and A3 can be substituted with small b. When you substitute that, then these respective productions will get converted to a Greibach normal form. Now all these five productions falls under two categories of Greibach normal form. So this example, we have taken a very simple example without any left recursive procedure. So we have converted that. So all these five productions comes under Greibach normal form. Now we go for the second one. So this is actually, we will take an example for left recursive production. So S tends to AA, bar B, bar A, and then A tends to SS, bar B. Okay. Now it is no null productions, no unit productions are there. Then these four productions comes under Chomsky normal form. So directly we apply for the third rule. So rename all non-terminals with respect to A values. So now S can be named as A1 and A can be named as A2. When you substitute it and rewrite the production, so we will get a production of the form A1 tends to A2 A2 bar A and A2 tends to A1 A1 bar B. Now when you take up the first rule, the first rule actually comes under AY tends to AJ, whereas I value is less than J. So A1 tends to A2. Okay, 1 is actually A1 is less than A2. So obviously this production rule is getting accepted. When you now check the second production is not falling under the category. So I value is actually greater than J value, isn't it? So A2 tends to A1. So I value 2 is greater than J value 1. So we have to convert that. So what to do for converting? So substitute the value of A1 into A2. Okay. So A1 is having a production A2 A2 bar A. So substitute these values in A2. When you substitute it, you will get A2 A2 A1 and A1, and already A2 is having a B production. So write B as it is. So we will get three productions after substituting A1 in A2. So now after converting that, after substituting A1 in A2, so this production becomes like this. So we have now five productions. Now when you take up the third production A2 tends to A2 A2 A1, this is a left recursive production because the left and right non-terminals are identical, isn't it? So now we just go for the theorem how to eliminate left recursion, that is A tends to A alpha tends to beta 1 beta 1 to beta n. So now we have to take all the non-left recursive productions. Non-left recursive productions are A small a capital A1 bar B. Okay, this is all non-recursive productions. So substitute, rewrite the rule A2 tends to small a capital A1 bar B. Then add Z to all these non-recursive productions, that is A1 Z and then B Z. Now when you just go to the next production, introduce a Z variable, so which is causing a left recursion is caused by A2. So anything after A2 is called as alpha, that is A2 A1 in the third production is called as alpha, isn't it? So now introduce Z and rewrite this production, that is Z tends to A2 A1 bar, rewrite the same A2 A1, add Z to that. So it is proceeding like this. Now, so convert that. Now after this, this production is getting, we have altogether 8 productions running from A1, A2 and Z. Now substitute the value of A2 in A1 and Z. Okay, because A2 is having now 4 productions, we have to take this all these 4 productions and substitute in the respective value of A2 in A1 and Z here. When you substitute A2 in A1 and Z, so the productions will be getting converted like this. Okay. Now when you take up this, we have altogether set of productions like this. 9. So altogether 17 productions are there. When you take up all the 17 productions, everything is falls under the Greibach normal form. It is starting with a terminal and non-terminal. So thanks for watching the video. Have a good day.